Hi there, welcome to Geotab Online Training. This is Carrie Carter, and I have with me Jordan Guter in the room, as well as Stephanie Volker on the line. And Stephanie is going to take us through a great deck today on the real deal engine data.
Okay, guys, thank you very much for making the time to attend the training today. I wanted to preface the training class with a little bit of background, if you will. The purpose behind today's training session is not to go through the software and show you every piece of data, every PID, and every data element that can be captured by the Geotab devices, but rather to talk about why engine data is important and what Geotab does differently with the engine data than other telematics providers, so that you can have confidence in the data and understand what it is that we're doing here. Okay, so engine data isn't just engine anymore. When we talk about engine data, it's very easy to think about, you know, things like fault codes and emissions data, but while the connectors in the vehicle did start out in that fashion, there's actually been quite an evolution of the data. In cars, it's typically referred to as the OBD, also sometimes called the ALDL connector. In the heavy trucks, it's called a J-bus connector, and it's the automotive one is typically a polygon, and the J-bus one is typically a circle with a varied number of pins in there. Regardless of the type of connector that's in the vehicle, the Go device talks to it in the same way. The thing that's important to note, and back in 1996 we started just so that we could have an in-vehicle link to that emissions and exhaust data. Today, that vehicle port includes instrument panel information like your VIN, your odometer, gear position, safety information, including the seat belts in many vehicles, engine maintenance information, fuel consumption information, overall engine health, and of course still that exhaust information is there. The idea is that it takes a lot to get all of this useful data off of the device. And over the next hour, we're going to talk about what Geotab does and why that's important to end user fleets. It's important to understand that while there is an OBD plug in every vehicle, all vehicles do not speak the same language, also known as the protocol. There's actually something called the Society of Automotive Engineers, SAE, that defines how set pieces of data must come off the vehicle. So you've got regular data that is regulated, that's your emissions and your fault codes and that kind of thing, and then you've got other sets of data called proprietary data. So if I'm an international truck and I've got a Detroit diesel engine in it or something like that, that engine is going to speak certain things specific to that Detroit diesel engine. And if I have a Navistar engine over here, it might speak a different language. So you have to understand that it's not just one and done. In fact, to further complicate things, there are a variety of different languages in the same vehicle. For example, in the OBD world, the light-duty vehicles, you can find that one set of data is coming from let's say I have a Toyota truck, but I have a Ford engine component in that truck. So if I want to get the engine data off of that, I have to talk to it in the Ford protocol, because that's the only way the engine knows that data. Okay? In the heavy-duty truck space, the engine data has migrated from J1708. That is just, that number, J1708, is just the Society of Automotive Engineers designation for that rule set for how data is going to come off. J1939 went into effect in 2008, and that basically just says that the data that's coming off that engine is going to be through that controller area network, just like the OBD engines have that same controller area network. So now I'm talking to different parts of the vehicle through that one diagnostic plug. Okay? What you need to do is capture the right information at the right time within a trip to make that data useful. So timing is key, right? When you turn on a vehicle and the vehicle starts to move, in Geotab's world we call that a trip. When the vehicle comes to a stop and you turn the key off, we call that the end of the trip. Okay? But there are times when we should be recording data that happens either before or after that ignition event. And I've got a couple of examples here. And again, I'm calling it engine data even though it's really not really engine data. If you look at the accelerometer on the Go device, if you've ever had to have a vehicle towed, the ignition's off, the vehicle's turned off, nothing's happening, no RPMs on the engine, but you'll notice that you can see where the vehicle's picked up by the tow truck. They put it on the flatbed, and how they drive it, you can track it all the way back to the body shop or mechanic shop or wherever the vehicle is going. You can see exactly where your vehicle ends up. It's quite interesting because the ignition wasn't on. How did we track the vehicle? From a Geotab world, your vehicle might get towed, and you want to know where it's located. The impound yard could hold your vehicle for 3 days before they let you know that they have it. You're racking up all kinds of fees. I want to know where my vehicle is, so we can track it while the ignition is off. Another example of why you'd want to be able to collect data from the vehicle even if the ignition was off is the classic hit while parked. You go into the grocery store or whatever, you come out, there's a big dent on your vehicle. Did you back into something, or did something back into you? By looking at the log details and accident data, you can see whether the ignition was on, was the vehicle in motion, how fast was it going, when that G-force was detected. If the G-force is detected and all those things are false, you know that you were parked and someone hit you. Very, very helpful with teenage sons as well, just saying. Okay, upon ignition, we first start the vehicle. If you've ever looked at the engine status data in the Geotab software, you'll see there's a ton of beginning of trip data points that are captured, and then there's another whole set of end of trip data points that are captured. Knowing what the instrument panel is doing, what the engine's doing, where the transmission is, can help you understand what's happening in the vehicle. You know, most trips don't matter. If you get into an accident, if something happens, if you throw a weird fault code, knowing what happened in relation to that data capture could be very, very valuable information for the fleet to have. Engine and maintenance data points are important to capture over the initial seconds at the ignition. The coolant temperature, level, the voltage, loss, and recovery as that vehicle goes through that ignition crank. You can actually see, and we're doing some really cool studies on this data now, that a vehicle that has an electrical issue, a starter, a battery, or an alternator, you will see a disruption in the data flow in the weeks leading up to that subsequent failure. It's a perfect signature. So what we're trying to do is isolate that data and be able to give you an exception rule so that you can say, here, this is what we're talking about. At the same time, the odometer and gear position is important to know. Obviously, odometer drives everything in a fleet world. If you're talking to a vehicle such as a General Motors vehicle, they have GM, but then they split their data into 2 data speeds. They have high-speed data and low-speed data. And they actually put those data on the same pin in their world because it doesn't affect anything that they do. In the Go 6 world, we had to use a harness called a GMLS to split that data into 2 pins so the Go device could interpret it for us. In a Go 7 world, we've actually made it so that that pin can talk to both the high and the low speed data sets at the same time, giving us the better data set all in one. Okay, now I just want to kind of talk a little bit about the difference in the way that we capture data from the way other telematics partners do it. And I will preface this by saying that, you know, done my best due diligence to understand what we do and what the other guy does, but that's not to say that that data can't change. They may change their algorithm. We're changing ours all the time. As of right now, this is what I believe to be true based on some interviews and things that I did. When Geotab records engine data, we use our algorithm to identify changes, right? So we're always talking to the engine and we're looking for changes in the data. For example, the coolant temperature rises by 4 degrees. Our algorithm says, we might want to know that, and we write a data point to that. The battery voltage drops by 250 millivolts, I think is what it is. We write a point to that. Something's changing. We want to know. We want to see what's happening. If you look at our data, there's data listed in a chronological order, and you can see that, you know, it's oftentimes you'll see 3 fault codes that trigger in a line. Perhaps this is one that hits every time you start the ignition. You'll see these fault codes again and again in sequence. You can see high RPMs and overheating situations. You can detect a lot of things by looking at how the data was recorded in the engine at the time of the event, as opposed to our competitors. They also have an engine diagnostic device, but they look at the data very differently than we do. They start the vehicle and they take a time slice of the data, and they say, okay, this is what the engine looks like. And then they wait 45 minutes and then they go, okay, now what is the engine doing? That is a very different data set than our rolling data. We're constantly capturing the information, watching the temperature, the voltage, the fuel level. All of these great pieces of data go up and down as the device moves through its day. Okay? If you just stop and think about how much can change in a 45-minute period, a lot of things could be different on that engine. So while the report looks relatively similar when I look at the data comparisons, the actual derived data that you get is very, very different, just to be aware. Now, the other thing about our device is that we try to be extremely easy to use. We make the setup super easy. The device auto-calibrates on install, so as far as the accelerometer goes, you don't have to, you know, position the device in any particular way, up and down, side to side. The device will auto-calibrate after about approximately 1 day of normal driving behavior. It can find forward and backwards and side to side and up and down, and it knows everything. And then you just have to do it. You don't have to think about it, right? In a Geotab world, there's no need to pre-assign the device. The VIN is recorded upon the initial install and every time the device is removed and placed in a new vehicle in the fleet. So it's always going to tell you what vehicle it's in. I'd like to get some stats for you on how many vehicles we read VIN on today, but the number is getting extremely high. We're trying to get VIN and odometer, fault codes, fuel, bar none off of every vehicle that we can get. But again, remember, with all of these proprietary protocols, it makes it very difficult. This is not easy data. If it was easy, everybody would do it. This is the differentiator for the Geotab solution to the other guys. It knows which kind of vehicles it's in. It knows that if it's this kind of Toyota with this kind of seatbelt, it's looking for seatbelts in a Ford protocol, such and such. And you can see that in the engine status data. If you look in MyAdmin at the VIN lookup, you'll occasionally see a different protocol. You know it's a Toyota, but you're seeing some other protocol, or vice versa. And again, it's because the parts manufacturers, Ford selling to Toyota, Toyota selling to Ford, everybody's trading technology, and so you've got to be a very, very smart device to be able to know how to get the data off of each individual vehicle. Okay, I found it quite interesting that Network Car Fleet does not record the VIN. The VIN is manually entered, and only the reseller has the ability to edit that. So if I change a device from one vehicle to the next, I have to go to the reseller to get that change. I can't just make the edit, and the device isn't smart enough to know that it changed vehicles. So while they do have this really cool feature that says, hey, I can let you know of all the recalls on your vehicle, if you don't update that VIN, you're going to get update notices for the wrong vehicle. So odometer and VIN are very important to Geotab. Okay, talking about vehicle compatibility. We do have one device that works with all different types of vehicles. The voltage ranges go from very, very low to very high. We do heavy duty, light duty, medium duty, electric, compressed natural gas, a ton of funky hybrids. You know, if we find a vehicle that we don't work on, we do our engineering work to make the device work on the vehicle. Geotab does not maintain a list of do not put our device in this vehicle type. It's just, that's not how we go to market. There is no don't use our device list, which is very unusual in our industry group. These Japanese makes down here at the bottom, Mitsubishi Fuso, the Nissan UD, and the Isuzu NPRs and all the flavors of the Isuzus, they're Japanese-built vehicles. They talk in a different language. You have to decode that language to get that information. We have found, and Carrie, correct me if I'm wrong, it's the Fuso that needs a separate harness to get the odometer?
Yep, that's correct.
Okay, so we have a problem. The Mitsubishi Fusos don't give odometer. We did the engineering work that it took to figure out that they put it on a completely different diagnostic connector that you have to go plug into as well. So there's a kind of a teed harness for the Go devices for a Fuso that would allow you to plug into the odometer port and get all the other rich data as well. Okay, so when you look at our fault data is one of those crazy things. You can get lots of different information off of these vehicles, and again, you've got lots of different systems feeding the vehicles. You can have a fault off of the HVAC system, the heating and cooling system in the vehicle can throw a fault in a CAN bus world. You know, all kinds of ones. The ones that I have listed here are actually quite common fault codes where you have a O2 sensor off kilter. The only thing that it's doing is affecting your MPG. So, you know, you can dig in there and replace them, or if the vehicle's of a certain age and you know it's going to go out of service shortly anyways, it's not killing anything. It does say that it's a low priority. The amber light on the dash is on. It's saying that there's, you know, something going on, but it's not system critical. You can still drive this truck. Does that make sense to everybody? I think it does. I think that the having the fault view summary lets you see, or exception view summary lets you see which of your vehicles are throwing the highest number of faults, and from those faults, you know, now I can prioritize which vehicles need to be serviced. So I just thought I'd kind of talk, since we're talking about the connected vehicle and the different data sets, base versus pro, the two levels of data that you can get off a Geotab device. Base is GPS data only. That is date, time, location, and speed. I did go ahead and include that it does include actual versus posted road speed because that's part of the mix there. Date, time, and location are basically your GPS points from which speed is derived. Okay? When I have the pro data, I have all of this GPS data, plus I have the engine data. And again, VIN, odometer, fuel, fault codes, the accelerometer data, the seatbelt data, all of this is what we include within our engine data. If I want to have any IOX add-ons, the driver keys, AUXs, HOS, Garmin, any of that, it has to be under the pro level of the data set. Okay, so talking about cool new features and functions. It's beta, and this is a new fuel function that's coming, teaser. It'll be coming to a software upgrade to you in the next few months, but I think it's just really cool, and when we're talking about engine data, we're talking about fuel data, we're talking about the Geotab difference, I would be remiss if I didn't show you how great this new thing is. Please forgive the fact that it's beta and it's very new, but the decimal points are going out a little ridiculously long on both the fuel consumed and the odometer. So basically, SV Go7 AT&T is the name of the asset. The left-hand column here shows you every fuel up event that this vehicle had from 4/16 to 5/23. After it has that first fuel up event, from one event to the next, now it can calculate the MPG. So you see my MPG going up and down as I go through my life here. 12.68 is the fuel consumed since the last fill up, and there's 80,072.99 miles on this vehicle. And you can see the odometer incrementing up in the far right-hand column. If I click on the little spyglass, looking glass, magnifying glass, whatever you want to call it, it takes me to the map and shows me where that fuel up event was on the map. Another function that it has, you can have fuel events on the buttons here. There's fuel events, that's the list that we looked at just a second ago, and then there's a graph, and you can see the fuel as I drain the tank, and then I get a fuel up event, and as I drain the tank and I fuel up event, and I drain the tank and I fuel up event. The data is being shown in liters at the moment, just because of the beta nature of the software, but you can kind of get a feel for, I ran the tank pretty close to empty, then I filled it back up, and away we went. So this is looking at the tank level of the vehicle at the time of the fuel event. And the idea behind this is because, you know, if you talk about fuel fraud monitoring and that kind of thing, you're looking at GPS points in relation to the gas pump. Was the vehicle close to the gas pump, and all of that good stuff. Well, that's one way to look at it, but you know, Geotab is a bunch of geeky engineers, so we decided it would be better to know what the fuel tank did at that same point in time. Is there a fuel transaction that corresponds with this fuel up event? How many gallons of fuel were pumped at this fuel up event? Does that make sense?
Sure does. I think it's great. Thank you.
All right. So I want to talk a little bit, because we consider in our connected vehicle data, we consider accelerometer data. It comes in with our engine data. Okay, that's just where we put all of our status data. It's not GPS data. It's not fault data. It's the status data of everything that's going on in the vehicle. So in that same bucket is our accelerometer data. It's really important for you guys to understand that accelerometer is very complicated. While it's in every one of the smartphones and Wii handsets and all these great technologies out there, using it for good to motivate driver behavior is a complicated process. Okay? So Geotab tries to make smarter data that is more actionable. We've devised a way of looking at automobiles, step-side vans, and tractor-trailers as 3 separate categories of vehicles because they function differently. A light-duty automobile has a lower center of gravity. It's lighter. It's just a different vehicle. A step-side van is a taller, higher vehicle with a higher center of gravity. And a tractor-trailer is heavy. It's got a high center of gravity, and it's also subject to a tremendous amount of vibration. To get the value out of that data, we have to be able to separate what is the noise from real data, what is a critical level of an event to what is a non-event. How do we separate the little things from the big things? There's a ton of great data there. I've had some fleets in the recent months tell me that the accelerometer, they're very concerned. They've tried other people's telematics devices with accelerometer, and they're just not sure that they find much value in it. And I want you to feel confident that a Geotab device that's properly installed, the data is rock solid. And by properly installed, the device cannot move independently from the vehicle. If the vehicle goes left, the device goes left. If it's swaying under the dash, it's not going to be valid data. Okay? If you look in the engine status data, you will see lots and lots of records of accelerometer data. Lots of things are going on in the vehicle. You think about how much movement you get forward, backwards, side to side, even up and down. Even though we don't count up and down against a driver, we do use it for things like rollover crash detection, and the data needs to be solid. So the device needs to be firmly mounted to the vehicle. I still believe that a good old-fashioned zip tie is the best tool for that job, but we're also coming out with a bracket that you can plug the Go device in, bolt the bracket to the frame of the vehicle, and slide the device into that bracket. Now we know that it's not going to move. So that you'll get a product announcement on that sometime next month, but it's a cool new little gizmo to make your installs easier and to help ensure that quality of the install. And we're also going to be delivering a white paper on our awesome crash test, and we ran it at low speeds, at medium speeds, and we didn't even get up to high speed. I think the highest speed we did was like 12 miles an hour. And it was shocking how much damage can be done to the vehicle and the subsequent thrashing of the driver at a low-speed crash into a solid object. So be on the watch for this new white paper that will be out June, July timeframe. Very informative on the rigor and the degree of testing that we put into making sure that your accelerometer data is rock solid and that you can count on it. Okay, so since we're talking about the engineering difference, Geotab's strength is knowing what we're good at and focusing our resources there. Again, I referred to us as little engineering geeks before. We take that to the nth degree. You saw our path on a fuel report doesn't look like anybody else's. We have to get to the data in a cost-effective and usable way. The list of data that fleets want from their telematics device never gets shorter. They only add to what they want. And if you go into the My Geotab software and you go to the engine diagnostics and you just open the list of all of the questions that are asked of engines, the number of data points that we can collect from the different kinds of vehicles is staggering. But let's say that we come up with a piece of information we don't have. We try to get odometer, VIN, seatbelt, that fuel level, fuel consumed data. It's a never-ending process. To complicate that matter, manufacturers are always constantly changing how this data is transmitted. They buy a new part, they play hide the seatbelt, thank you Ford. There's a lot of different things that go on there. Geotab strives to give you all of the data elements. If we find one that is not there, or it's proprietary to a particular manufacturer, then we have to go decode that data. We have a means of doing that. In the old days, and by old days I mean 2008, 2009, 2010, we would put an engineer on a plane and fly them to the problematic vehicle. They would use a scan tool and identify how that data is coming off that vehicle. We've since engineered a remote scan tool that we can do from our Geotab offices. The way that this works is a device is installed and the troublesome data is tested. For example, if I want to get seatbelt off of a particular make and model of vehicle, the reseller opens a case and says, you know, this VIN class, I'm not getting seatbelt the way I used to get it, it's just gone or it's bad or whatever the case may be. We schedule an appointment to go out and plug in the device to the vehicle. We do a test on that data set. We plug and unplug the seatbelt, plug and unplug the seatbelt, whatever the case may be, and listen to where the engine records that change of data. And once we see the PID, and it's like primary identification, or I don't even remember what PID stands for, but it's the engine codes. The PID is being used, and what is the value for on and off for that seatbelt? Now we know what we're looking for. So the discovery phase is this remote diagnostic is done. Now we have to go through and write firmware code to request the data in this new way. Then we have to go through the rigorous automated testing. If it sounds like firmware is an easy fix, and it can be, it just isn't a quick fix. It goes through the automated testing, and that is testing this new version of the firmware on every version of equipment we've ever had, all the way back to Go 2, and testing it on every engine diagnostic that we have in our library, and all of the variables that can happen in between. So then we go into the next phase where we go back to that fleet that said that they had a problem with the seatbelt, and we have them alpha beta test the firmware. Where alpha test is basically on our vehicles, beta test is back on the customer's vehicles, and then once it passes all the tests and we know that there's nothing bad going on with this vehicle firmware, then it becomes the base firmware for all Geotab devices. All of the existing devices in the field, all 400,000 of them now, will get that firmware, and every new device that's ever built from Geotab will have that firmware. The firmware never changes. We don't branch our code. We always use the same firmware for everything, which is another thing that differentiates the Geotab, is that we have one device. Whether it's a heavy-duty or light-duty vehicle, the only thing that you need to change is the shape of the plug so that you can attach it to the vehicle. This is a massive change from other manufacturers out there in the industry. And finally, we take all of this great engine data, and we've got safety data, we've got fleet maintenance data, with fuel efficiency, optimization, underutilized assets, all of this great data that we have. You can now connect that data to other applications like the Navistar On Command, which is a commercial truck maintenance software that would allow you to get the fault codes off the vehicles. If you haven't seen the On Command system, it's really cool. We'll arrange a demo for you, but it can tell you where is the shop that has the part that's needed to fix that problem, which is the closest shop to where your vehicle is right now. But the software development kits allows this kind of third-party integration. It allows the fleet management companies to consume this data for their fleets. It allows you to, as the reseller, to create custom reports that show these are your vehicles in the most need of assistance. And with the add-ins, you can take the software development kit, take all of this great rich data, and create your own add-in graphic or whatever you wanted. Show me the least utilized assets. Show me every vehicle in the fleet that doesn't drive at least 5 miles a day for at least 20 days per working month. or however you want to look at it. There's a ton of great information there.
Stephanie, thank you so much for sharing with us. And with that, I'd like to say thanks, everybody. We'll see you next time.